Okay, so this is mechanisms with fast first step. And so for these type of problems, you need to do two things. One, the elementary steps, right here, the fast and slow, these two steps need to cancel and create this. And the second thing is that the rate law of the slow step has to equal the rate law of this slow step has to equal the overall one. So the overall is given to you because unless you have data, you can't determine it on your own. So they give you the overall, and then the next thing we have to do is we have to see if this equals this. So we cancel. So we see that N2O2 and N2O2, they're on both sides, so we can cancel both of them. And then we're left with 2NO, O2, and then 2NO2. So it matches. The next thing is rate law. So the rate law is determined like this. They gave us the rate law for the overall. So so for this one, for the fast step, it's in dynamic equilibrium, meaning so this rate law will equal this one. So we can set them equal to each other. So if we do the rate law of this one, it'll be KNO2 because this becomes 2NO and NO is the concentration and then 2 is the coefficient. Because in an elementary step, you actually can use the coefficient as the exponent. So it's NO to the second power, and then and then the forward reaction is K, so it'll be K times NO, and then it'll equal the reverse reaction, which is K minus 1, and it's N2O2, and then the coefficient's 1, so it'll just be that. So we want to isolate N2O2, so we divide each side by K negative 1, and then that gives us K NO2 over K negative 1 equals N2O2. Okay, so now we make the rate law of the slow step. And the rate law is rate equals, we can say it's K2, the K constant 2, N2O2, coefficient's 1, so no exponent, or the exponent's 1, and then O2, and then once again its exponent is 1. So now we have that rate law, but the slow step, the rate law of the slow step has to equal the overall, and right now it doesn't. But we can plug in N2O2 because we just solved for it. We can plug this entire expression into here, and so we do that. And then also another thing, K, like just a normal K, equals K2 times K1 over K minus 1. So if we know that, then all of this simplifies into rate K NO2 O2. So the slow steps rate law now equals the overall rate law, and then it cancels, so it's followed both steps, showing that this mechanism is a valid mechanism.